In this question, we have a building that is 50 meters tall, and there's a person standing at the top with a ball. They drop the ball from the top of the building. And we want to know what is the ball's velocity as it hits the ground, and how long did it take for the ball to reach the ground. Before we start this question, I want to make it clear that this is free fall motion. So the only force that's acting on this ball is gravity, and so the ball's acceleration as it drops to the ground is due to gravity. And when your acceleration is due to gravity, your acceleration is always equal to negative 9.8 meters per second squared. Now that we understand this motion, let's look at the first part of our question, which says, what is the ball's velocity as it hits the ground? Let's start by looking at what was given. We know the acceleration is the acceleration due to gravity, so it's negative 9.8 meters per second squared. We also know the initial velocity, VI. VI occurs at the top of the building when the person lets the ball go. Because the person just drops the ball, the initial velocity is 0 meters per second. We also know YI and YF are initial and final positions. The initial position is when the ball's at the top of the building, and the final position is when the ball hits the ground. So we can say YI is equal to 50 meters, and YF is equal to 0 meters. And to remind us what we're solving for, we are solving for VF, which would be the velocity when the ball hits the ground. Now let's think about what kinematic equation we could use to solve this question. We are missing delta t, so we can't use any kinematic equations that include time. That means we need to use the Vf squared is equal to Vi squared plus 2a delta y equation. From there, we can just plug in our values and solve for Vf. And now notice, in order to solve for Vf, we have to take a square root. And the answer to a square root can be either positive or negative. So we have to decide what is the correct sign of our final velocity. Well, the ball is falling down, and vectors that are pointing down are negative. So our velocity vector is negative, and that means the final answer should be Vf is equal to negative 31.3 meters per second. Now let's move on to part B of our question. Here we are asked, how long did it take for the ball to reach the ground? So we're solving for delta t. And I've already wrote all the information we were given on the diagram. So now let's just think about what kinematic equations we can use to solve for this question. Because we already solved for Vf, we have quite a bit of information, which means we can use any of these three kinematic equations. Now you might be wondering, what kinematic equation should you use? Well, technically you can use any of them. But I'm going to go with option 1 because I want to use the kinematic equation that only includes variables that were given in this question. So let's go with the YF is equal to YI plus VI delta t plus 1/2 a delta t squared kinematic equation. All we have to do is plug in our values, rearrange for delta t, and in the end we find that the time it takes for the ball to reach the ground is about 3.2 seconds. And that's how you use the kinematic equations to answer free fall questions.